Hello, my name is Karina,
And I'm Sophia.
and today we will learn about the applications of reflected and refracted light.
We will guide you step by step and show you some cool examples in real life that will help you understand these concepts better. Let's start with the basics. What is total internal reflection?
Well, total internal reflection is a phenomenon that occurs when light passes from a more optically dense medium to a less optically dense one, at an angle so large that there is no refracted ray.
Yet, it is not the only phenomenon related to light. It can be a bit confusing, so here's a diagram of some phenomenons that can occur.
Okay, so in this diagram we can see how in the image displaying ray 1, there is a ray which goes at an angle I, and as it leaves the surface of the water, it refracts.
The diagram for ray 2 shows the way in which the incident ray is so great that the refracted ray lies on the surface of the water.
Wait, doesn't that have a special name?
Yeah, it's called the critical angle. It technically is the incident angle that is the cause of the refracted ray that lies right along the boundary of the substance.
Yeah, like we just saw in diagram 2.
Lastly, we can see total internal reflection in the diagram of ray 3. In this diagram, the angle of incidence is greater than the critical angle. I think one of the coolest parts of these phenomenons is refraction and its effects.
That's right, I especially like mirages. For those of you who don't know what mirages are, they are the plane shift in position of an object caused by refraction of light.
Yeah, and we have the perfect way to demonstrate this phenomenon to all of you watching.
All you need is a pencil, oil, water, and a cup.
To do this lab, fill a clear cup halfway with water, then slowly dip a pencil in and watch as it moves across the cup. You will notice how it looks broken with the exception of the middle in which the pencil does not look broken, yet looks wider than the real pencil. You can also do this with oil to see the difference because the oil has a different density than water.
When light travels through a medium, it travels in a straight line. Yet, when it reaches the second medium, the light path bends. When the light crosses a boundary between the two media, it continues to travel in a straight line with a different direction. Yet, if the light from the object you are watching changes medium on the way to your eye, it distorts the image that occurs. Knowing this, we should see the way in which the pencil in our experiment will demonstrate this phenomenon.
Yeah, so what happens is that as the pencil is moving from one side of the cup to the other, the light of the pencil is changing medium from water or oil to air, and vice versa. Therefore, as we stated before, the sudden change of medium as light travels to your eyes causes distortion, such as the pencil looking broken. Yet in the middle, the pencil does not look broken due to the fact that the light it reflects does not change medium.
We can also see how the image of the pencil under the liquid looks wider than the actual pencil above.
Yeah, this is the way refraction works.
A similar scenario can be viewed in daily life.
Really? Where?
Well, if you have been outside on a hot day after it has rained, you will notice that as you look out onto the road and a car passes by, you can see an image directly under it.
Yeah, isn't that a mirage?
Yeah, the way this phenomenon works is that just like glass and mirrors, water can serve as a medium to reflect light.
Wait, but that really doesn't explain much.
Well, you're right. In detail, what happens is that on a sunny day, the sun rays help heat the road. As a result of this, the air just above the road is significantly hotter than the air on top. Knowing this, we have to keep in mind that the hotter air is less optically dense than the cooler air. Therefore, as the light is coming down from the sun, it travels in a straight line through the more optically dense cool air, yet when it reaches a hotter, less optically dense air near the road, it bends, causing refraction.
That sounds similar to what happened with the pencil in the lab.
Exactly.
I feel like we are forgetting to tell them about something. Oh yeah, how could we forget dispersion? Dispersion is the breakup of light into its spectrum.
Also, in dispersion, the velocity of a wave depends on its frequency.
And a light's frequency dictates the color it produces.
Yeah, so we can get all the colors of the rainbow. I hope your day will reflect the new light of our teaching.
See you next time!